In this problem, we will implement a stack that has a min element functionality, so we can retrieve the minimum element with constant time and constant space. So let's start off with the class definition. We'll name it as minStack. We need to initialize several variables. And we'll initialize a stack. We'll set up our constructor to create a new instance of a stack. Named the same as our stack here. Next, we'll work on our push method. We don't have to return anything, so it's void. Passing in an integer x. Let's check if the stack is empty. So if the stack is empty, we're going to push 0 into the stack. And set the minimum as x. Else, if the stack is not empty, we'll store the difference between the input x and the current minimum value. So if x is less than the current min, set x as the value for min, or update the value of min. That's it for our push functionality. Now for pop. here we will want to return the integer that we pop. If the stack is empty, we're going to throw a not supported exception. And give the user a little bit of detail. Here. We're going to pop and set the value of pop equal to our variable pop that we've initialized up here. Okay. Awesome. I'm going to try to fit the rest of this pop method on this page. We'll see where we end up. If the value we pop is less than 0, so what we're checking right here is if this value used to be a minimum value in our stack. We'll assign the current min to our variable hold, so we can hold that min. We'll set min equal to the difference between min and the element that we've popped. So we're returning it to the min that it had before this element was pushed onto the stack. Now we'll return hold. Because if pop is less than 0, that means it used to be a minimum for the stack at the point in time when this element was on the top, which means that the current min is equal to the original value that entered our push method here. And if pop was not less than 0, we'll return the following. We'll return pop plus min. This restores, so what we pushed into the stack was x minus min. Returning the popped element plus min restores the value of x to what was passed to our push method here. So that is the end of our pop method. On to a new page to avoid confusion. And this is the both the important part and the least intense part of this entire algorithm, where we define the getMin method. will return an integer. And you've probably intuited that we're going to simply return min here. And the rest of it's on the other page, but we need to close off the entire class, so we'll close that there. Okay. I'll just toggle back and forth between these pages as needed. So, it seems that I need to toggle again. Let's write out some driver code to interact with this class. We'll define main. And what we'll do is create a new stack of min stack. And we can push a few items in, pop something out, and see what our min is. See if the min is correct. So we'll push 4. Let's push 3. Let's push 2. We'll write to the console the value returned from popping. And then let's access the getMin method. Okay, so this is the driver code that we'll be using to interact with our MinStack class. So let's revisit the definition of the problem. Implement a stack with a minimum element functionality that has O of 1 time and O of 1 space. So let's just corroborate that that is indeed true. And yes, it is. Here's getMin. We simply return the min. That has a time complexity of that is constant and a space complexity that is constant. So, just as a quick note to ourselves about the driver code that we wrote, we're pushing 4, pushing 3, pushing 2, popping, and then we are getting them in. So let's walk through what would happen here. Great. So when we call, so first of all, when we initialize the new stack, let's see if I can do this. Amazing. When we initialize the stack here, that created a new instance of the stack. So we're going to push 4 if, and let's draw out our stack here. Awesome. So if stack.count is 0, which right now it is, there's nothing in our stack, we're pushing 4, remember? Let me move that. We're pushing 4. We're pushing 0 into the stack and setting the min as 4. And that's all we do. We'll push 3. So if stack.count is 0, nope. Else, we're pushing x, so 3, minus the current min into the stack, which is 3 minus 4. Oh, I can't see that. Let me draw this in a place that's better to see. So we're pushing 3 minus 4, which is -1, into the stack. If 3 is less than 4, then the min is now equal to 3. So min now equals 3. Okay, push 2. 2 enters. If stack.count is 0, no. Else, stack.push 2 minus the current min, which is 3. 2 minus 3 is -1. If 2 is less than 3, that's true. Now 2 is the new min. Okay. Now we'll pop. So I'll move this. If stack.count is 0, no, not true. So now we're assigning the popped value to our variable pop. So I'll write off to the side here, pop equals 2. If, oh, that's not true. These are the mins, and the value that we're popping is actually -1. So pop is -1. If pop is less than 0, that's true. So that means that 2 was at some point a minimum value. So if pop is less than 0, hold is assigned the current min, which is 2. Min is now assigned, comment this, min is now assigned to be 2 minus -1. So the difference between the current min and the popped value. Min is now assigned to be 2 minus -1, which is 3. Awesome, that's what we want. And now we will return hold, which is 2. So we return, this got popped. Min is now 3. And will return 2, which means that console.writeLine 2 gets written to the console. And that's not in view. Console.writeLine 2 gets written into the console. Now we have one last thing to do here. We want to enter the getMin method. So remember, the current min is 3. And that holds true because the minimum between, let's write this out also, the values that were entered into the stack. They just happen to be analogous. The values entered into the stack were 4, 3, and 2 is removed from the stack. So 3 is indeed the min between 3 and 4, which is our current value of min. So what we will do is return 3. Return the min, which is 3. So three gets written to the console.